Sine, cosine, and tangent ratios are used to solve problems with right triangles. Which ratio we should use depends on the problem we're solving and the information given. For example, say we're given triangle ABC and we're asked to find the value of angle A. Now, since two sides are equal, we know that this is an isosceles triangle, which means angles A and C will be equal. So that also means that if we were to draw a perpendicular line here from angle B to side AC, it would create two equal right triangles. We'll call this right angle here angle D. So triangle ABD is a right triangle. We know that the hypotenuse is 45 centimeters. And since side AC is 22 centimeters, then side AD must be 11 centimeters, and that's the adjacent side to angle A. To find angle A, then, we use the cosine ratio. The cosine of A equals the adjacent over the hypotenuse. So the cosine of A equals 11 over 45. The cosine of A equals 0.2444. Now, using a trig table or the inverse cosine function on a calculator, we find that a cosine of 0.2444 is for an angle of about 75.9 degrees. You can also use the cosine ratio to find the measure of a side. So, for example, say we want to find the height of this triangle, which is this new side BD that we had drawn in here. We now know that angle A is 75.9 degrees, and we know angle D is 90 degrees, so we can find half the value of angle B, which is this angle right here. We'll call it theta. 75.9 plus 90 equals 165.9 degrees, and we know that angles of a triangle total 180 degrees, so 180 minus 165.9 equals 14.1 degrees. So angle theta is 14.1 degrees, and side BD is adjacent to angle theta, so we can use the cosine ratio to find the measure. The cosine of theta equals the adjacent over the hypotenuse. So the cosine of 14.1 degrees equals the adjacent over 45 centimeters. Now, using a calculator or a table, we find that the cosine of 14.1 degrees is 0.9699. 0.9699 times 45 centimeters equals about 43.6 centimeters. So side BD is about 43.6 centimeters.